Hello everyone, welcome back to my YouTube channel Tulsi Physics. If you are new to the channel, do subscribe and click the bell button for more updates. So it's a continuation of the last video, the product of two vectors. So as we know, product of two vectors is of two types, dot product and cross product, where the dot product yields as a scalar, which is also called a scalar product, where the the cross product gives us vector as a result, and it is also called as vector product. Now, so we stopped there in this components. So what to do to get the product of A and B, that is A dot B, with components alone. So before figuring out that, we must know this thing, that is I vector dot j vector gives us what? Similarly, j vector dot k vector gives us what? Also, I dot I gives us what? So we should know these things. So it's nothing but the three axes: y-axis, x-axis, and one more axis is z-axis. All these three are perpendicular to each other. That is, they are mutually perpendicular to each other. Now, already we know that I corresponds to x, j corresponds to y, and k corresponds to z. Now see, I and j are 90 degree to each other. So the value will be modulus of I vector into modulus of j vector into cos of 90 will give us, as we know, cos 90, the value of cos 90 is 0, so it will give us 0. Similarly, j and k will also yield us 0, whereas the I and I, it's an I vector, and one more I vector is also on it again. Let me say it again, I vector. One more I vector is placed here. Okay, now the angle between these two vectors is 0 degree. So on consideration, modulus of I vector into modulus of I vector is into cos 0. I'll get 1 here. Whereas modulus of I and modulus of I, considering it as unit vector, will get 1. So ultimately, I dot I is equal to 1. Now, so coming back to the problem, A dot B is equal to I vector to j vector, that is A vector dot B vector is equal to I vector plus 2j vector plus k vector dot product of 3I vector plus j vector plus k vector. Let me say one more time, that is I dot j dot k, whatever the components, if the components are different, that is I, j, k, or k and I, if the components are different, the product will yield us 0. If the components are same, the product will yield us 1. Remember this. Now, considering I as a multiplicand for these three things. So now, we'll get I vector into 3I vector. I dot I is 1 and 1 into 3 will get 3 plus I into j is 0, so we'll get 0 again. I into k will get 0 again, so we don't bother about the values of I, j and k. Now for the second term, as we know for all the three, 2j into 3I will get 0 again, so I'm not writing it. 2j into j into j is 1, 2 into 1 will be 2, so 2 I'm writing. Similarly, j and k will be 0. Here, all the 3 will be 0 and the k into all the 2 will be 0 and the k into k will give us 1. Now the answer will be 3 plus 2, 5, 5 plus 1, 6. Now A vector dot B vector is equal to 6. So the 6 is a scalar. So as I told, dot product yields us a scalar. Now let's see what happens for cross product. So A vector cross B vector is equal to I vector plus 2j vector plus k vector cross cross product of 3i vector plus j vector plus k vector. So that is a simple way for this. If you have studied matrix, you may come across the matrix and determinants. You may come across this thing, that is I vector, j vector, k vector. The component of I vector, that is the coefficient of I vector, is 1 here. The component of j, that is the coefficient of j, is 2 here. Coefficient of k is 1. Similarly here 3, 1 and 1. By doing determinant, we can find the vector product of these two vectors. So as I told, I vector dot I is equal to j vector dot j is equal to k vector dot k is equal to 1. Similarly, we are having I vector cross I, j vector cross j equal to k vector cross k uses 0. Since I and I makes an angle of 0, I cross I will give sine theta, on sine 0 will get 0. And we'll have a circle like this. So there will be three things on consideration, that is I, j and k. If it is given with I vector cross j vector, we'll get k vector. If it is j cross k, we'll get I vector. That is in a cyclic manner. If it is against a cycle, just like the determinants, I vector is taken here and this will be left. This will be left 2 into 1, 2 and minus 1, 2 minus 1. Similarly 1 minus 3 and 1 minus 6 are written here. That is I vector, j vector and k vector. So the answer you can see here is a vector. In case of a dot product, we got a scalar which is 6 for these two vectors. That is a dot b is a scalar, so it is also called a scalar product. Similarly a cross b, we are getting a vector again, that is I vector plus 2j vector minus 5k vector. That is the cross product gives us vector, which is also called as scalar, that is a vector product. Now, so this is product of two vectors. Similarly, we are having product of three vectors, that is scalar triple product and vector triple product, and also for 4 vectors are also there. So this is Tulsi Physics, and do subscribe if you are new to the channel, and comment any other topics that you needed. So click the bell button for more updates. Thank you.